Welcome to the fifth video of the physics lecture series for the National Science and Mathematics Olympiad. In this video, we will introduce pressure. Take a look at these two pictures. On the left, a child is lying on a bed made of nails. He looks happy, but how can this be? Why don't the nails hurt him? On the right, there is a skier. Why do skiers use long skis instead of just sliding down using their boots? For both of these questions, the key to the answer is pressure. But what is pressure? It is important to know whether a force acts only at one single point or is spread out. So pressure basically tells us how concentrated the force is. To get an intuitive picture of this, a force acting on a small area causes a large pressure. If the same force acts on a large area, the pressure will be small. Now we can understand the smiling child on the bed of nails. His weight is distributed over many nails, so the pressure at each nail is very small. Hence, they cannot hurt him. Similarly, the skier's weight is distributed over the large surface of his ski. That's why he is not sinking into the snow. If instead he tried to ski just on his boots, the pressure on the snow would be much larger and he would simply sink in. Pressure is also the reason why trucks have many more wheels than cars. The larger weight of the truck needs to be distributed over many more wheels so that the pressure on a single wheel will not be too large. We can define pressure more precisely as the perpendicular force on the surface per unit area. To express it with a formula, P equals F over A. Here, F is the force in newtons, A is the area in square meters, and P is the pressure in Newton per square meter, which we call Pascal and denote with PA. As a form of pressure, let's now talk about the pressure in fluids. If you have ever tried scuba diving, you know that the diver feels that water exerts pressure on all parts of his body, and the feeling of pressure increases the deeper he dives. When mountain climbers set out to climb high peaks, they have to contend with the opposite problem. The higher they go, the smaller the air pressure is around them. For example, at around 5,000 meters, the pressure is only half of the value at sea level. Because of this, each breath contains much less oxygen at these heights, and the body of the climber needs to adapt to these circumstances. But how can we physically describe the pressure in fluids? All fluids, so all liquids and gases, exert pressure on objects immersed in them. The pressure of the fluid affects in all directions on an object that's immersed in it. The pressure doesn't just come from upward, otherwise this would push the object deeper and deeper at an ever-increasing rate. Let's now see the formula describing the pressure in the fluid. It was found in experiments that denser fluids exert larger pressure. For example, the pressure of water is larger than the pressure of the same amount of air. The pressure also increases the deeper we go into the fluid. This seems very logical. The deeper we are, the more fluid is weighing on us from above. Therefore, the fluid pressure at a point is calculated by this equation. Pf equals rho f times h times g. Here, Pf is the pressure of the fluid, rho f is its density, h is the depth of the point below the surface of the fluid, and g is the gravitational acceleration, so around 9.8 meters per second squared. When a fluid is exposed to the atmosphere will also exert pressure on it. Hence, in these situations, we have to calculate a combined total pressure. The pressure coming from the fluid plus the pressure coming from the atmosphere. Take a look at these two figures. On the left one, the container is open, so we need to take into account the pressure coming from the atmosphere. On the right, the container is closed, so there is no extra pressure. You can think about it like fluids stack their pressures. If there are multiple layers of different fluids above you, you have to take the combined effect of all of them into account when calculating the total pressure. Thank you for your attention and see you in the next video.